Carbon-14 is what scientists use to date anything that was once alive. Interestingly, there is a trap when trying to date anything after 1955. Carbon-12 is the normal carbon that makes up 99% of all carbon on Earth. Carbon-14 is slightly heavier, much rarer, and radioactive. It forms when cosmic rays smash into nitrogen atoms in the upper atmosphere. For every 1 trillion carbon-12 atoms, there is roughly one carbon-14 atom. That's how rare it is. Carbon-14 isn't stable. It decays back into nitrogen-14 over time. The rate isn't perfectly predictable for a single atom, but statistically, half of a sample will decay every 5,730 years. They call this duration its half-life, because it's the time it takes for half of the substance to be gone. So if you had 10,000 carbon-14 atoms, after 5,730 years you would be left with 5,000 atoms. This decay acts like a clock, meaning if a bone or a tree has 50% of its original carbon-14, it's roughly 5,730 years old. After 7 half-lives, the substance would almost be completely gone. In other words, you can't carbon date anything older than 40,000 years old. While alive plants or animals constantly exchange carbon with the environment, keeping their carbon-14 levels in balance. But once they die, that exchange stops, and the carbon-14 clock starts ticking. This is why you can't carbon date a living tree. It's still swapping carbon with the air. But here's where it gets tricky. Carbon-14 levels in the atmosphere aren't constant. They've changed slightly over millennia due to solar activity and ocean currents. Scientists adjust for this using calibration curves. This was not really complicated. But then came 1955. Between 1955 and 1963, nuclear bomb tests flooded the atmosphere with extra carbon-14. When bombs detonated, they converted atmospheric nitrogen into carbon-14, nearly doubling its levels in the northern hemisphere. After the 1963 test ban treaty, levels began dropping as carbon-14 mixed into oceans and plants. And this is the trap I mentioned earlier. If you carbon date something that passed away after 1955, its carbon levels could very likely match 2 dates in the chart, and without context, you can't tell which is which. This creates major headaches for forensics and archaeologists. Determining whether remains are recent or from decades ago can require additional context or taking more steps in the process.